Hello, welcome to Waka Waka Breaking It Down for the financial applications. In this video, we're going to look at the TI Inspire and how to graph and solve equations. As you can see down here, we have an equation where we're looking to solve for the exponent. Algebraically, you need to use logarithms to solve for this, but we haven't learned that yet in this class, so we're going to do it graphically. So we're going to graph the left side and we're going to graph the right side and look for the intersection, which will be our solution. In addition to that, we're going to summarize growth and with like financial, we'll have a kind of context with financial, like investing money and getting interest on it and interest on top of interest, and going to summarize like how it changes when you compound differently. Do you compound once a year, twice a year, 4 times a year, every month, every week, every hour? How does that look, right? So that's what we're going to be doing. So let's get right to it. You can see this first equation. This is coming off of a warm-up problem we did that where you get $1 million and then you're going to invest your $1 million. And I want to know how long it's going to take if I get 5% per year to reach 1.5 million. So I'm going to gain $500,000. Okay, so let's graph it out. So I got $1 million and then I'm gaining 5%. So in your calculator, you'll see right above the dock button, there says plus page. So if you go to this blue and then plus page, you can insert a graphs page. Should look like this. I'm just going to type in my $1 million times, and then the 1.05, that represents 100% of what you started with plus an extra 5%. So I always think of this as a percentage. So I'm going to multiply my money times 105%. The 100 for what you started with plus an extra 5%. Okay, and then I need the years. So in this case, X is going to represent years. So for every year, I'm going to get 5% of whatever my money is. And then after that, I get 5% more of whatever the new amount is. And it keeps going, right? So you multiply by 1.05 over and over and over again for every year. Okay, so when I graph that out, boom, you're going to be like, oh, I didn't get the graph. What's the problem? Well, it's always the window. So you always have to go in and check for the window. I mean, right now I'm going from 1 to 10 on my window, but in reality, I invested $1 million, didn't I? So go to the window settings, and I just went to menu to do that. And you just got to logically think this out. Like, how many years is it going to take to get my money back? I don't know. It's 10 now, but let's try 20. The Y window is really the one that you got to pay attention to in this case, because we started with $1 million and we're going up to 1.5 million. So I'm just going to go ahead and make this like 1,700,000, something like that, so I can see. Let's see. See, there's my graph. I can see what's going on now. So you have to just logically think about what your numbers are so you can see it. Now, if I want to graph the other piece to see where they're equal to each other, you hit the tab button over here on the left. It says tab. Hit the tab button and this bar will come up. You can scroll up to see your previous equation, and then you can arrow down to start a new one. Now I want 1,500,000. So I'm just going to graph that, just a number by itself, and you'll see that shows up there. I can grab my screen, pull it around. I can grab the tick marks and pull that down, right? There's different ways to do it so you can see. I know a lot of people like to use the zoom feature, but to be honest, that sometimes just causes more trouble because it's going to change the y-axis as well as the x-axis, and like both of them change. So in this case, we really wanted the y-axis to change the scale, and we didn't want the x-axis to change at all, right? So it's better just to use your window settings, logically think it out, and put in some numbers that make sense. Like, what are you looking for, right? Where's it at? Okay, so now I got my graphs. Now I can do intersections. So again, hit menu, and you'll see right here it says analyze graph, and there's this intersection button. We did this with the quadratic unit, so hopefully this is just a review for you. Now, a lot of people try to go right on it. That's actually not good. You want to go a little left of it and then click, and then go a little to the right and click, and then you'll get your answer. So 8.31, right? So it took 8.31 years for my $1 million to turn into 1.5 million, right? That's the intersection. So 8.31 should be my answer to this first one. On the bottom of this sheet, you'll see all the answers are there. So if you're looking this up, you can scroll to the bottom and see your answers down there, 8.31 years. Okay, the next one, same thing, except now we're changing from 1.5 million to 2 million. So we're gonna double our money, right? Oh, how do I do that? Well, just hit your tab button. It gives you a new line, but you can scroll up to see your previous number. And I'm just gonna change this to 2 million instead of 1.5 million. Hit enter. Oh, it's gone. Where did it go? Well, it's up here, right? We changed from 1.5 to 2 million, so it went a little higher. And then just redo my intersection. So menu, analyze, intersection, little left, little right. There's my number, 14.2. So it takes a little longer, but after 14.2 years, I'll have doubled my money, right? And of course, that's at 5% yearly interest. Okay. Now they do make this an inequality just because they're trying to get you to realize that if it says inequality, then that's the time that you're going to get more than $2 million, right? So starting at that particular time, you're going to start to get more than $2 million. Right? It says more than, greater than or equal to. Here's just equal. It's pretty much the same idea of finding that cutoff, but this one's just saying, well, after that time, you're going to have more than 200 or 2 million, right? So you can see, again, you can just pop down and look at the answer real quick and say, yeah. So this is including and after 14.21 years, right? Where it's going to be more than that. Okay, now the next pieces, starting with number 2, excuse me, are really trying to get you to look at how the compounding changes over time and what these formulas should look like. So the first scenario is you're investing $1,000, you're getting 6% interest annually every year, right? And you just want to find out how much you have on your credit card. So you're not really investing, are you? You're borrowing 1,000, but you are not going to be paying it back. You're just like borrowing it and let it sit. And then the bank is going to charge you interest. So it's like how much you owe the credit card, right? It's not very realistic because normally you pay, every month or something, you pay off your credit card, in the real world. But we're just trying to imagine like what happens, like we're trying to make it simple, right? So what happens if you just let it sit there? What happens? How much do you owe? Sorry. So we to get this equation, like we're going to see 2 and 3 and 4, they're all going to be very, very similar and they're going to build off each other. So I'm trying to kind of do these all together a little bit. All right, so when you write these things out, just keep that basic equation in mind. It's like, okay, this is how much I have or how much I will have. This is my starting amount. I'm going to start with 1,000. This is going to be my percentage. So I've got 100% plus I got to add on my 0.06. We change percentages into decimals. And then we say, how many times am I going to compound that, right? So we get something like this. So after 1 year, I would just put 1 into this x value and just say 1,000 times 1.06, and you'd get your answer. And then put 3 in there and get another number. Put 6 in there, get another number. Now, it should make sense. The more time that goes on, you're going to get a bigger and bigger number, right? So if I threw this in my calculator, let's go 1,000, 6%. All right, so I'm going to go back to my calculator page. If I did 1,000 times 1.06 raised to the first power, right? And then I'm going to change that to, do we do 2 or 3? We do 3, 6, 3 and 6. So I'm going to change that to a 3, copy and paste it down, change it to a 6. All right, so you can see that I will owe more and more money I'm going to owe, right? One way to look at it is like, let's say after this 1 year, I took that money, and then just so it makes sense to this is not what you'd normally do, but I just want it to make sense to you. So I could take that amount of money I had after the first year, multiply by 1.06, and that would be the second year. And I can multiply that by 1.06, and that would be the third year. I don't know if you can see how that, you see how that matches what we had up here, right? It matches that. And then I could do the same thing, times again. That's your 4th year, 5th year, 6th year. And you can see how after 6 years, that's how much I get. So the idea is you're just applying, you're just applying 1.06 over and over and over again to increase the amount of money that you owe, right? The shortcut to that is to just use the exponent, right? Just use the exponent to show how many times do you want to apply the 1.06. So there you go. That's the kind of the short way of doing things, right? But this is a great kind of image of what's really happening. Okay, so those answers will be at the bottom. And then we're trying to say, what's the general equation for that? So let's look at the answer for that. So you're going to see on number 2, those numbers that I calculated are there after 1 year, 3 years, 6 years, how much money you owe. What's the general equation? Well, I already wrote that down for you. They use t instead of x, but same difference. And they use the amount as a function of the time, right? So that's really nice format. Now, as we go on, so that's your general equation is this, right? So whatever my principal was, whatever my starting amount was, is the P in this case. And then whatever my rate was would be here, right? So it's 1 to start with, and then plus how much you're going to be gaining or adding on to it, right? If we were decreasing money, then this would be subtraction, right? If you were taking away a percentage or something, then that's what that would be, right? So that's your general equation for right now. It does get more complicated though, right? Okay, so then looking at 4, 5, and 6, things you can see how things are going to get more complicated. Let's actually just peek at the answers first. You can see this is going to end up with 2t, this is going to end up with 4t, and this is going to end up with 12t. So we're looking at how that changes along with our rate. How does the rate and that exponent kind of change together? And those all kind of go together. So let's look at 3, 4, 5, or 4, 5, 6. So there's 3 we already did. So 4, 5, 6. So here we go. Number 4. Again, we're investing $1,000. It's still 6%. But in this case, they're going to compound it what we call semi-annually. Semi-annually. That means twice a year. So instead of 6% once a year, we're going to half that and do 3% twice a year. So every 6 months. So twice a year, right? So when they try to set that up, they say, well, it's not exactly the same as before. Sure, it's $1,000 to start with. It's going to be easier if I just go to the answers. Let me just pop down here. So you can see we're right here right now, right? So it's $1,000 to start with, but instead of gaining 6%, I'm only going to gain 3%. But the difference now is that I'm not going to just raise this to the first power, like over 1 year. I'm not going to compound it once. I'm going to compound it twice. So 1 times 2, like 1 year, you're going to multiply by 2. So to get this number that they have here, right? Let's go back to here. Let's start this off. 1,000. Whoops, 1,000. 1.03. And I'm going to raise that to. Now, if I go for a full year, right, a full year, then that's going to be compounding twice because I do it once the first 6 months and then I do it again the second 6 months. So that's 1 year's worth, right? I think the question asked for only 6 months though, right? Whoops. Here we go. Back. Sorry, I'm jumping around a little. Yeah, it asked for only 6 months. So after the first 6 months, I'm only compounding it once. So that's where they get their value from. We just put 1 in. That's where the 1,030 comes from. If I compounded it for a full year, then I'd have this. I'd have the 1,060, right? If I did it for 18 months, so that's three groups of 6, right? If I did it for 2 years, that would be 4 times. If I did it for 3 years, right? I compound it twice a year for 3 years. That's 6 times total, right? Every 6 months for 3 years. And so then that's what you'd get, right? And we could just, go on and on and on. So this is kind of going up by 2s for every year, right? So if I said 4 years, 5 years, right? So I'm going like 2 years, 3 years, 4 years, 5 years. So you can see how those kind of double because I'm compounding it twice a year. So when I start working through these problems and I look at the final answer, like the final equation of what that represents, you can see why this 2t comes up. Because you're compounding twice a year for every single value of t, which is in years. I just really keep in mind this is every 6 months. So how many times are you compounding this? And it happens every 6 months. This is the same, the rate matches that. So this is a 6-month rate. So this power has to be how many 6-month periods are you doing, right? I hope that makes sense. Number 5, you're going to see is the same thing, except for now we're going to compound it 4 times a year. So, if it's 4 times a year, the rate is going to get divided by 4. So, whoops, that keeps popping. So my 0.06%, instead of being divided by 2, is going to be divided by 4. So that's 1.5% now, right? So I could use the same type of equation and change this to 1.5% now. So if I put a 1 in there, what does that represent? Well, remember we cut it in 4, right? So we took the 6% divided by 4. So this is every quarter of a year. A quarter of a year is every 3 months. So every 3 months, that's what this represents. So after 3 months, I have this much money if I compounded it every 3 months. So 4 times a year. If I did this would be 6 months, right? That would be 6 months. And then I would have, let's see, if I did 4, that would be 1 year. If I did 8, that would be 2 years, right? You're compounding it 4 times a year. If I went 3 years, that would be 12, right? 3 times 4. So 2 times, or 1 times 4, 2 times 4, 3 times 4. So hopefully you start to see that it's times 4 up here, times years, right? So if it's 3 years, that means this number needs to be 12 to show that you're compounding it 12 times over those 3 years, because you're doing it 4 times per year. And this rate will match that. So this is a quarterly rate, and then this number needs to be in terms of quarters. So these numbers, you can see the 1,015 is there right here, right? That's what we calculated. The 1,061, that's right here, right? That's 1 year's worth. And then we have the 1195. That's this one right here, right? Where we did 3 years worth. Okay, so those are the answers to number 5 up there if you're looking at your sheet. But this is kind of the final equation for compounding quarterly at 6% annual interest. That 6% gets changed to match what we're dealing with, but it started off at 6%. Okay, then number 6, if you look at the question sheet, it starts talking about same thing, but now instead of compounding it every quarter, we're going to compound it every month. So how many months in a year? Well, there's 12, right? So what percentage do I need to use? Well, it's 0.06 to start, but I have to divide that by 12 to get a monthly rate. So 0.06 divided by 12. So I could use this 0.005 and change my equation a little bit. So this equation I just wrote at the bottom down here, right? That one is showing, well, I start with $1,000. I'm putting in the monthly rate now, not the yearly rate. And then the power has to be in terms of months now. How many months? So if I put a 1 in there, whoops, that's supposed to just represent 1 month. If I put a 2 in there, that's 2 months. So if I put in 6, well, isn't that a half a year? And if I put in 12, isn't that 1 full year? 12 months is a year. So this would be like how much I got after 1 month. And this would be like how much I got after 1 year, right? If I wanted 3 years, then this would end up being 36, wouldn't it? Okay, so that's in terms of months. So same idea. They went ahead and just left this as 0.06 over 12. You can see that right here. I went ahead and figured out what that was up above here at 0.005. Same difference. Doesn't matter which way you write it. It's the same thing. And the reason they have 12t here now is because they're leaving t as years. So they're saying for so many years, you can multiply that by 12 and get the number of months you want. But the main goal is to match the units of your rate, and the exponent units have to match. So if this is a monthly rate, this has to be the number of months. If this is a quarterly rate, this has got to be the number of quarters. If this is the number of, semi-annual half years, right? Then this has got to be a half year rate. So they have to all match up, right? Just like in the beginning, this was the number of years. So this is a yearly rate. They all have to match. That's the real key to this. The rate and the number of times you're compounding, that unit kind of has to match. So they wrote it this way on number 6, so you could see on number 7 and 8 the general format of it. So this is your general format. How much are you starting with? What's your basic rate? Sometimes you have to divide that to get the rate that you want, whether it's a quarterly rate or a monthly rate or daily rate, or you could even do hourly or minute rate, right, if you wanted to. And then this will represent how many of those quarters or how many of those months or days that you have, right? So again, this unit has to match this unit, the total, right? For me, a lot of times it's just like, instead of just memorizing the formula, just really think that through and just think, okay, what rate do I have? So then what power do I need? Like, those just have to match. And it'll become more clear what you need to do. We're going to find that sometimes down here, you don't actually divide. You would go like R times N, and then that whole thing up above, you would have T divided by N. So we're going to find that as well on some of the problems that we have. And that's a situation, like all these situations we just got done doing, you were going less than a year when you were compounding it. So this situation that I just drew is when you're going more than a year to compound it. Like, let's say I compound once every 3 years, right? So I need a 3-year rate, and then I need a 3-year time period up here. So this is for when you're when the compounding gets really big, but here's when the compounding gets really small, right? Is it more or less than whatever T is? Like if T is a year. All right, so that's why I say it's best to just logically think it out, because it's not always exactly like this every single time. It's not. So you just have to be careful and logically think what you're thinking through. Think through what you're doing, right? Okay, so that was number 8. We were summarizing that basic formula, right? And where we just invest after 1 and 3 years at different types of compounding, right? This was compounding monthly, et cetera, et cetera. Okay, so hopefully that makes sense. You need to know how to kind of work with that type of equation. You also need to know how to graph and find intersections to solve. We don't know how to do logarithms yet. So, excuse me. We're going to learn, next unit, we're going to learn how to do logarithms and solve these things algebraically, but we don't know how to do that yet, so we have to use our graph, okay? All right, that's it for this video. Thank you very much. Ask questions and get help always.